So this is our exam review. So we're going to have some new material and some old material. So let's talk about we'll start with the old material first. So if you remember, we started off in chapter 10, which was the counting principles. So we had the fundamental accounting principle. And really everything we've done is based upon the fundamental accounting principle. And it's basically says that if you have you've got a multi-part event. So you might be flipping a coin 5 times, you may be picking people out to be officers, you may be picking people for a committee, those kinds of situations. And there are the number of choices for each part. So let's say it's multi-part. So it's, there's first part is n equals 1, n equals 2 is the second part, n equals 3 is the third part, n equals 4 is the fourth part, and you just keep going on. And for each step, there are n choices. So I'm going to say, what's a good thing here? So let's say step 1. Yeah, I actually wanted to use a subscript of 1. So I'm trying to think of another word. Let's use m. M is the number of choices. For each step. So if you have a 4-part process, say, where n goes from 1 to 4, you're going to have the number of steps associated with part 1 of the process times the number of steps in part 2 of the process times the number of steps in part 3 of the process and the number of steps in part 4 of the process. And that sum gives you the total number of arrangements that you have. So 2 of the special cases of this using the fundamental accounting principles are permutations. And permutations are where order is important. And secondly, repeats are not allowed. So if you pick a person for a position or for a place, they can't win, say, first or second place. They can't be both president and secretary. So that's what the repeats are not allowed. So the cases of that are races, officers, and anything where order is important to the final answer, and where repeats are allowed. So there'll be a couple of cases where they're going to be permutations or combinations, which is what we'll talk about in a second. For permutations, the number of arrangements is determined by using the permutation formula. So what you have is n things taken r at a time. And that is going to be equal to n factorial divided by n minus r factorial. And let's say, for example, it's 8 things taken 2 at a time. So you've got, say, 8 people, you're going to choose 2 officers. You have n is 8, r is 2, so you get 8 factorial divided by 8 minus 2 quantity factorial, which is 8 factorial divided by 6 factorial. And 8 factorial is 8 times 7 times 6 factorial divided by 6 factorial. 6 factorials cancel out. You get 8 times 7, which is 56. So there are 56 ways that you can choose 2 officers given 8 people to choose from. And how it relates to the fundamental accounting principle is that when you pick a president, say you're using this example of presidents, say a president and a secretary. When you choose the president, which is step one, you've got everybody to choose from. So you have 8. So from the fundamental accounting principle, you've got step 1, which is there are 8 choices. But once you choose somebody for president, there are only 7 people left for secretary. And that's the 2-step process, and you multiply it together and you get 56. So that's using the fundamental accounting principle. This is just using the permutation formula, given that the problem or the scenario fits the requirements for permutations, where order is important and repeats are not allowed. So that's a permutation. You can go back and look at your test and see which ones were permutations and combinations. Then you have combinations, and this is where order is not important. So things like committees, where you're not assigning officers, but you're just choosing people, but still repeats are not allowed. So the cases of combinations is things like committees. So if you see the word committee, you know to use combinations. You can also think of like sampling, if you're sampling stuff. So if you go back to the first test, you'll see there's where we use combinations were committees and where we took a sampling of something. For combinations, you have n things to choose from. You have taken that r at a time. The formula is n factorial over r factorial times n minus r quantity factorial. So let's just do the same combination here. You have 8 things taken 2 at a time. How many 2-person committees can I get from 8 people where the order is not important? And it should be less than where order is important. So n is 8 and r is 2. So you get 8 factorial over 2 factorial times 8 minus 2 quantity factorial. So 8 factorial over 2 factorial times 6 factorial. 8 minus 2 is 6. And remember that 8 factorial is 8 times 7 times 6 factorial divided by 2 factorial, 6 factorial. The 6 factorials cancel out. So you've got this, compared to before, you've got this extra 2 factorial in the denominator, which 2 factorial is 2 times 1. So this ends up being 56 divided by 2, which is 28. So that's how many 2-person committees you can get. Now, if you have like 2 committees, again, look back at your test. So this was the case of Democrats and Republicans, and there were, there were 30 people, let's say on the Republican side. I don't remember what numbers I used, but there was on the Democrat side, let's say there were 25 people to choose from, and here you had a 3-person committee, and here you have a 2-person committee. And the question is, how many different arrangements can you have? Well, for each committee, you have a certain number of arrangements, and then you use the fundamental accounting principle to take the result you get from this and multiply it by the result you get from that to get the total number of possible arrangements of committees. So when you have 30 people taking 3 at a time, so again, it's a committee. So you take 30 things taken 3 at a time, and to get the final answer, you multiply that by the result of taking 25 things 2 at a time. So you can evaluate these 2 things using this approach and then multiply your answers together to get the final number of arrangements. So this is using the fundamental accounting principle. This is using the fundamental accounting principle. And then you multiply the 2 together using the fundamental accounting principle again. One thing to remember for this particular case was that, about committees. What's going on here? Why do we have this extra term? This extra term in the calculation compared to permutations is this number factorial. So dividing this by this number removes the the order factor, what order they're in. So without the 2 factorial, that gives you the number of combinations or number of arrangements where order is important. But if you have 2 things, you can either have A and B, or you can have B and A. When you do this part, that's important, whether you have A first and B second, or B first and A second. Whereas by dividing by that 2, you remove the effect of order on it. That's the whole idea. If you remember back to, if you go get back and look at your test where I said use fundamental accounting principles, you had it was like 7 things taken 3 at a time, and you had to, or 10 things taken 3 at a time. So where order was important, you had 10 times 9 times 8. To remove the importance of order, you divided by 3 times 2 times 1. 3 times 2 times 1 is the number of ways you can arrange 3 things. So the denominator is using the fundamental accounting principle as well. Okay, so that is that situation. Let's see what else. Is there anything else that I want you to know from chapter 10? No, that's pretty much it. Okay, so chapter 11 was probability. And remember, the probability of an event occurring is the number of, this involves counting, the number of times event E happens divided by the total number of events in the sample space. This results in a number between 0 and 1. Probability is always between 0 and 1 because the denominator is the largest number you can get, and this numerator can either be 0 or anywhere between 0 and the denominator. And so when you take the ratio, the probability is between 0 and 1. So we had the case of, if you go back to the last test, we had the case of just using the definitions of probability for the picking a cat or something like that. I don't remember what it was. You can go back and look at it. We also had conditional probability. So that was the probability of event A and event B happening was equal to the probability of event A happening multiplied by the probability of event B happening given that event A happens. And this was the pet store problem, both the homework problem and the test problem. Be a card kind of problem. Then we have conditional probability. So let's use cats instead of dogs here just to give you an example. Let's say we have 7 Persians, 3 Siamese, 2 short-haired, I don't even know if that's a breed, 5 tabbies. Okay, so we got 4 different kinds of cats. So conditional probability is when you pick 2 things, and the first choice may impact the probability of the second. So in the case of conditional probability, you've got with and without replacement. Well, with replacement is kind of boring, so we're going to do without replacement. So the question here is, what is the probability of picking a Siamese and a tabby randomly?
without replacement. So you've got two parts. You got two steps. You pick a cat. So again, you wouldn't throw the cats into a bowl, but you'd probably, what you would do is you would give the cats some identification number. You know, these would be 1 through 7. These would be 8 through 10. You take those identifications, you'd put them in a bowl or a hat. You'd shake it up. You'd randomly pick something out of there. And so the probability of picking a Siamese is going to be the number of favorable events. Well, for this one, the favorable event is picking a Siamese. So there are 3 Siamese, and divided by the total number. So if we add these together, we'll get 17. So the probability of picking a Siamese initially is 3 out of 17. Now, when you're doing an and kind of thing here, you're doing and, meaning you're picking more than one thing, then you multiply the probabilities together. So the second choice may be dependent upon what happens for the first choice. Well, if I pick a tabby, there's still, you know, this is initially right here, right? This is second choice. Well, if I initially have this and I pick one of the Siamese, then my choices now are these numbers. So the total number of cats, or total number of cats that are still available, is 16. So I make that modification to my what's available, and then I answer the question, what's the probability of picking a tabby? Now without replacement, so I didn't replace the Siamese. So there are 5 tabbies, and there are 16 cats. So I can do that calculation, and you know, if there's some way of simplifying it before I do it, but in this case I don't think I do have it. Yeah, I don't think there's anything. I think you just have to multiply them out. 3 divided by 7. Well, 3 times 5 is 15. 17 times 16 is 272. And actually, that's just, you can't simplify that any. Okay, so that's it. So what is the probability of picking 2 short-haired? So the probability of picking for the first pick, so the first short-haired, what we do is we go back and we look at, we're going to erase these because these don't apply. So every time you do a new thing, we always start out with the same number of initial choices. So we have 2 short-haireds, we have 17 cats, so the initial probability of picking a short-haired is 2 over 17. The probability of picking the second short-haired, given first short-haired, well, if we go back here and we say, okay, well, we pick a short-haired, so there's going to be one of those left over. There'll still be the same number of the other one. So again, the total number of cats is reduced by 1, but not only is the denominator in the second probability change, but the numerator is changed too. So instead of 2/17, we have 1/16. And so the probability of 2 short-haired is going to be, meaning we pick 1 short-haired and then the second short-haired, given the fact we're not replacing, is going to be 2/17 times 1/16, which is 2/17 times 16, 2 over 272, but they're both even, so that's going to be 1 over 136. So that's probability. So you really have, and the only other case is where you might only have one of, if I only had one short-haired to start with, I couldn't pick two short-hairs. That would be not a possible thing. But usually if they're different cats and it's two choices, then the denominator is reduced by 1 because we have one less cat, and we just use whatever the numbers are here initially. Now if you pick two of the same cat, then you have to reduce both the numerator and the denominator by 1. Again, multiplying them together. The third case would be if you only started with one kind of cat and you took 1, that would leave 0 left. And so you'd have to take that into account. Sometimes the answer would be 0, probability of 0. Okay, so that's conditional probability of two events, the probability of event A happening and the probability of event B happening. Now a lot of times they're independent of each other, so you can have replacement or like shooting a free throw. The probabilities don't, the second shot still has the same probability. Doesn't matter whether you made the first one or not. Or
had the case of the cards, choosing cards. And that was more associated with or, the word or not. So what we had is the probability of event not happening was equal to 1 minus the probability of the event happening. So that's the complements principle. And we had the probability of event A or event B occurring. That was equal to the probability of event A occurring plus the probability of event B occurring minus the probability of event A and B occurring. Again, I'll copy the review from the previous thing. That'll come right now. Okay, then we had binomial probability. That's not right. Binomial probability. And binomial probability was the case of where you had an event that could happen or couldn't happen. And it doesn't have to be a 50-50 thing. Well, you did use binomial probability for flipping a coin. If you look back at the test for chapter 11, we did a coin and we did a basketball. For the coin, the probability of success was 50%, 0.5, and probability of failure was 0.5. We also had the basketball probability. It all comes down to the probability of an event happening. So a probability of success, so many successes out of so many, it's usually 5 out of 8 or something like that, success. So really it's the probability of the number of, probability of a certain number of successes given number of trials. So you could be 5 out of 8 getting heads, making free throws, and it's binomial because it either happens or doesn't happen. You can't have, like if you had the probability of getting 2 out of 3 heads, you can still do that, but anyway, what we said was the probability of, let's say, n out of we'll use X. X is the number of successes, N is the number of trials, is equal to, use the combination formula, N taken X at time. So this, might be 3 out of 4. So 3 is the number of successes, 4 is the number of trials. So this is where N goes here, 4 things taken 3 at a time. Then you have the probability of success taken to the X power, and the probability of failure taken to the N minus X power. So let's just say whatever it is. Let's say the probability of success, which I guess we just use P as the probability of success. So probability of success, let's say it's 0.70, whatever the trial is. Therefore, the probability of failure is 1 minus that, because you either succeed or you fail. And then let's say 5 out of 7 trials, whatever the trials are. So the probability of getting 5 out of 7 is 7 things taken 5 at a time, 0.7 to the 5th power times 0.3 to the 7 minus 5, which is 2. So it's the 2nd power. And then you multiply this together and you get the answer. So that's a binomial probability. It uses probability as well as just counting all the different ways that things can come out successful. Okay. Now,
games, gambling games. Okay, so then you have, then we go to binomial probability. So examples of that are anything where we say, one thing can happen or another thing can happen. It's either something positive or something negative. The biggest 2 examples we did were flipping coins and shooting free throws. So remember, the probability of X events happening is you take N things taken X at a time as a combination. Then you take the probability of success raised to the X power and the probability of failure raised to the N minus X power. So that's the equation. You just have to figure out what N is, what X equals, what P equals, and what Q equals. And Q is equal to always 1 minus P, because you either have a success or a failure. So, free throws. Let's say you take seven shots, make 3. So the N is always the larger number. Larger or equal, we could say 7 out of 7, but this is always the largest of the 2, and if they're the same, then it's the same number. X is always the smaller number of the events that are occurring. So if you're flipping a coin, if you flip the coin 5 times, what's the probability of getting 3 heads? 5 would be N, 3 would be X. In this case, the probability is the free throw percentage. So let's say it's 82%, so use 0.82, and Q is going to be 0.18, which is 1 minus this number. And then all you have to do is plug it into here. So the probability, if I asked what's the probability of making 3 out of 7 shots, I would take 7 things taken 3 at a time as a combination. Probability of success would be 0.82 raised to the 3rd power, which is the number I made, 0.18 to the 4th power, which is 7 minus 3, this minus that. And so then we can do this combination number separately. So remember, it's n factorial over r factorial times n minus r quantity factorial. That's the equation for combinations. So you get 7 factorial over 3 factorial times 7 minus 3 quantity factorial. So the order of operations says you do this stuff in the parentheses first. And don't forget the factorial here. A lot of people last time forgot. This is a factorial. It's not 3. It's 3 factorial. So then you get to this point and you say, okay, which one of these is bigger? Well, 4 is bigger than 3. So I'm going to rewrite the numerator in this form. I'm going to go down until I get to 4. Use the factorial. Divide by 3 factorial and 4 factorial. Well, you can cancel those out. Remember, don't forget that that's 3 factorial, not 3, or you'll be off by a factor of 2. And you can just do the math, or you can simplify, and you get 35. So this number is 35, so the probability of making 3 free throws out of 7 is going to be 35 times 0.82 cubed times 0.18 to the 4th power. And you get 0.0203. So the probability of getting making 3 out of 7 is 0.0203. So, if I said all 7 shots, make all 7 shots, then that means x equals 7. So in the case of something out of something, 3 out of 7, it's obvious what this number is. But if I say all 7 shots, then that means x equals 7. So you take 7 things, take it 7 at a time. Probability of success raised to the 7th power. Probability of failure raised to the 0 power. This minus that, using that. 7 things taken at 7 at a time is 1. And then you'd raise 0.82 to the 7th power. And any number raised to the 0 power is 1. So I get 0.249. So it's much, for an 82% free throw shooter, it's much more likely for them to make 7 out of 7 than it is for them to only make 3 out of 7. Because this number is much bigger than that. So that's how free throws work. Coins, flipping coins. So let's say 6 out of 7 heads. So the thing about coins is the probability of success. We don't have to specify that. For the basketball, we had to say what it was, but for coins, it's always 0.5. It's either heads or tails. So if I ask you what's the probability of getting 6 out of 7 of the coins is heads, so in this case, n is equal to 7, x is equal to 6. So the probability of getting 6 heads is going to be C, use n here, use x there, probability of success, which is a head, times the 6th power, which is this number, times 0.5 to the 7 minus 6 power, so that's 1. This is 7. Remember, if you have this is 1 and this is a number, then you use this number. If this is a number and this is 1 less than that number, then it's just the number. If it's 0, 7, 0, you get 1. 7, 7 would be 1. Okay. So we can skip that step And you really see that all these cases you get 0.5 raised to the 7th power. 0.5 raised to the 7th power times 7. So I get the probability of getting 6 out of 7 heads is 0.0547. If I said all heads, then x equals 7, n equals 7. Yeah, so if they say all of something, then you use the same. These are the same, so the answer is 1. This is 0.5 to the 7th power. 0.5 to the 0 power is 1, so you get 0.5 to the 7th power, and you get 0.0078. So that's the probability of getting all heads. This is the probability of getting 6 out of 7 heads. The most likely one would be 3 out of 7 or 4 out of 7. It's the middle. It's the middle one. So if you flipped a fair coin, most likely you are going to get either 3 heads or 4 heads. It's very unlikely to get all heads or all tails in 7 flips. If you continue to do that, the probability that you have a fair coin would become less and less because the probability of what's happening is less and less. Anyway, flipping coins, probability of success and failure are the same because it's a 50-50 chance. If you say 6 out of 7, the smaller number is x and the larger number is n. You just plug them in.
From the statistics standpoint, we haven't been tested on that, so I'm going to go into a little more detail on statistics. Statistics, okay. So we had the measures of central tendency, which were mean, median, and mode. So the mean is you sum values together. So whatever your variable is, you add all the values together, and then you divide by the number of data points, whatever your data points are. So it's an average, basically. Mean is average. Median is you order the data and then choose the middle value. So that there's the middle value is different depending upon whether you have an odd or even number. So I'm going to ask you to review that. And the mode is most frequent value. So this has to be something that's you have the data point more than one time, at least more than one time. And the one that has the most listings of a particular value is the mode. We tend to use mean and median more so than mode. So if I give you some data, be able to calculate the mean, the median, and the mode. Standard deviation. We did that in your project, and what we had was a table where we had the data, we had the deviation, we had the deviation squared. So let's just kind of set up a simple table. So this is this would be the data, which we'll call x, say. So let's say I'm just going to, it doesn't matter how many data points I have. Procedure is the same. So be able to fill this kind of table out. So here you'd have the deviation, here you'd have the deviation squared. So the first thing you do is you add the numbers together. So it'd be 1 plus 2 is 3, plus 5 is 8, 8 plus 7 is 15, let's actually make that 8, just because then it'll come out easier to do calculations. So you get 3 plus 5 is 8, 8 plus 8 is 16, so the sum equals 16. The mean equals 16 divided by 4. The sum divided by the total, you get 4. So the deviation, this is going to be 3 less than the mean. So you take this number and subtract the mean. So 1 minus 4 is negative 3. 2 minus 4 is negative 2. 5 minus 4 is 1. 8 minus 4 is 4. So those are the differences between the individual values and the mean. Now we don't add the deviations together. If you do, you'll get 0 if you've done everything correctly. Then you square the deviation, so you get 9. So you square these numbers, and they all become positive because anytime you square a number, it becomes positive. And then you add this column together, which would be 9 plus 4 is 13, plus 1 is 14. 14 plus 16 is 30. So that's the sum of the deviation squared, and your standard deviation is equal to the square root of the sum of the deviations, which is that number. So you just use that number there, divided by n, and n is the number of data points. So we have 4 data points minus 1. And so you'll get 30 divided by 3, which is 10. The numerator is 30, divided by 4 minus 1, which is 3. Take the square root of that, and you'll get 3.16. So that's how you calculate the standard deviation. You know, I'll give you not a huge number of data points, but. And the final thing I want you to be able to do is to use the normal distribution information. Okay, so that is the part of the assignment for chapter 12. Remember, what we're talking about here is that if you plot the normal distribution, and we assume that if we assume it's normal, then half of the data is greater than the mean. This is the mean. Half the data is less than the mean. If I ask what percent, or what's the probability or percent of data between two values, let's say I pick that, so let's say the mean is 50, and this is 52, and this is 47. So I ask you, what's the probability of randomly picking a number between 47 and 52, where the mean is 50. So we had a number of different cases. In this case, when you have the values on either side of the mean, you're going to add the areas that you calculate. So I'll provide that table for you. So if you have the book, you can look at this and make sure you know what you're doing. But be prepared to do any of the situations that we did for the project. So in this case, we calculated a z-score associated with each value, 47, 52. So you get 47 minus the mean, which is 50, divided by the standard deviation, which I'll give you as, let's say it's 3.2, and that's, I use S instead of sigma, so it's population standard deviation. Not population, but so that's the standard deviation, 50. So I would divide by 3.2, the standard deviation, and I'm going to get a z-score associated with that. 47 minus 50 divided by 3.2, which gives me negative 0.94, and there's going to be an area associated with z equals 2, and we're going to use the positive version because our table is only for positive z, and then you have 52, so you have 52 minus 50 over 3.2. Again, 50 is the mean, that's the value, this is standard deviation, so you get 52 minus 50, which is 2 divided by 3.2, which gives you 0.63. Now I'm rounding it up to 2 decimals because that's what the table does. That's as close as it gets. So you'd have the area associated with the Z equals 0.62, and now we have to go to the book, or you have to go to your sheet that I've handed out. It's chapter 12, 400 and something, I think. No, 600 something. Section 5. Okay, so now I've got my table out. Hopefully you've got your table out. Make sure you know what you're doing here. So the area associated with the z-score of 0.94 is 0.326. And the z-score associated, or the area associated with 0.62 is 0.232. And so the total area is going to be equal to 0.326 plus 0.232. So that's that plus 0.232. So that's 0.558. So the probability of being between 47 and 52 is 0.558. So there's 3 problems. So three that you're going to use the same data for. So one of them may be this or may not be. You just have to go back and review the different possibilities. And the best thing to do is to draw the picture and figure out, do I add them together? Do I subtract them? Do I add to 0.5? Do I subtract it from 0.5? I'm not going to go through all of those. I'm just telling you, you need to know how to do this. Okay, so that was chapter 12. 12, yeah. Okay, 13. Chapter 13 was personal finance. So I'm going to let you go back and dig this information about. We talked a little bit about it in the previous test, but I want you to know, and you can write it down in your sheet. So in your previous one, I asked you about, what were the 3 kinds of investments, and I said it was cash, bonds, and stocks. And I want you to just know basically what these represent, what the risk, reward, and volatility is for each one of those. Risk, I'll write it down, risk, reward, and volatility, and and it's going to be high, medium, or low, depending on which one it is. I'm going to ask you to write down the definitions for the following. So, what is a mutual fund? What is a 401k? What is a traditional IRA? And what is IPO? Okay. And we talked about this in terms of stocks. IPO stands for initial public offering. So just research that a little bit, summarize it in a few sentences. Traditional IRA stands for individual retirement account. A traditional IRA is a way of saving money where they do not tax you on the money that you invest while it's growing while it's accumulating wealth. They do tax you on the resulting final value when you take money out. And typically this is a better choice if your tax rate is lower in retirement than in your working life. 401k is similar to a traditional IRA, except this is through your work and this is done outside of work. Sometimes you can actually, we didn't talk about it, but you can take, at some point you can take your 401k and convert it into an IRA, and that's because basic idea in terms of the regulations and limits and are the same between the two. And then mutual funds are just a group of stocks, typically representing a certain type of business, or they might be an index fund where they're related. They're related because they all belong to a particular stock index, like the Dow Jones or the NASDAQ or the S&P 500. Or it could be mutual fund where you group mutual funds together that are used to make up a target date fund. But we talked about target date funds. That was one of the questions, but I just want you to have an idea of mutual funds. So look those up, write the answers down, be ready to put them on your test. We did this on the test, but I'm going to ask if you didn't get it right, you can go back and watch the review previously. So I'll insert that here as well. So this is payment schedule for an installment loan. So if you didn't get it right last time, study again because you'll need it. Okay, then we go to chapter 7. That was linear equations in one variable. So just go back and look at the previous test. Make sure you can do that stuff. One thing we didn't cover was section 7.5, which was exponents. So you can write down the laws of exponents, like the product rule. A to the n times a to the m is equal to a to the n plus m. I'll give you the page that the laws or rules are on if you want to write them down. So I think there's a summary sheet here somewhere. Yeah, it's on page 334. Also, speaking of that, you can have, we had 4 tests, based chapter 10, one in chapter 11, one in chapter 12, which was a project, chapter 13, and then 7, I'll say 7 and 8. So you can bring up to 5 sheets in if you want, so you don't have to try to cram all that stuff in there. But all the rules for exponents are on page 334. So I'm just going to ask you to review your homework. I don't think we ever got to scientific notation, did we? So we're not going to cover that. And then chapter 8. We only did the first 2 sections, so make sure you can calculate distance between points. Plot points on a graph. So I may give you 2 points, ask you to plot them on the graph, and then calculate the distance between those 2 points using the distance formula, which is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And the 2 points are x1, y1, and x2, y2. And then the second chapter was plotting a line given a point and slope, and also calculating a slope given 2 points. So let's go ahead and do that. Just do an example for you. So let's say we have -2, 7 and -5, -6. Okay, so I'll give you some piece of graph paper that you can use to plot the points. It'll look very similar to this. Okay, so everybody should have no problem doing this. So you go -2. Let's label our axes X and Y. Let's put some scale in on it. So make sure that's in there. So we go from -10 to +10 with 0 in the middle. -10 to +10 with 0 in the middle. So each grid line will represent 1 unit. So we get 1, 2 in the negative X direction, +7 in the Y direction. Then we go -5, 1, 2, 3, 4, 5, and then -6 in the Y direction. So right there. So this is the line. So that's the line connecting those 2 points. And so the number is going to be on the order of, you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13 units this direction, and it's 3 units that direction. So it's going to be slightly more than 13. That should be the answer. So what I'm going to ask you to do is write these above the numbers, x1, y1, x2, y2. The equation for the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then we can make sure we plug those in there. So x2 is -5 minus x1, which is -2. Square that. Take y2, which is -6, and subtract y1, which is +7. So here we have -5. This is a negative. So this is -5 plus 2, which means you're going to make it more positive. So it's going to be closer to 0. So you get -5 plus 2 is -3. Square it. That's where I got my 1, 2, 3 from here. And then I have -13. So this is 13, like, but there's it looks like a positive slope. It is a positive slope, but it doesn't, all we're cared about is the distance, because we square it, whether it's positive or negative. And so you get 13 squared, which I think is 169. 13 squared plus 3 squared, and you get 178. Square root of 178. And you just leave it as that. Just leave it as a square root. You don't have to simplify it. And I am going to do it just to show you this close to 13. So if you do it, you get 13.34. So it's slightly more than 13. Okay, so that's using the distance formula. Now, let's go ahead and calculate the slope of that line while we use the same points. So again, the slope is y2 minus y1 over x2 minus x1. And we go here and write them down. -6 minus +7 divided by x2, which is -5 minus -2. So that gives me -13 divided by -3. So these numbers here should be the same numbers that you get here. At least the magnitude should be the same. But here the negatives cancel out, so you just get +13 over 3. Don't leave the 2 negative signs in here. So that's the slope. So what that means is for every, you get rise 13, so you go up 13, and over 3, positive 13 over positive 3. And that's what slope means. So now to look at the second case, let's say you're given the point -2 comma -6, and your slope is, actually let's change that to positive 6, and your slope is -5 halves. So I'll give you a piece of graph paper. What you do is you plot the point. Again, let's label the axes. So you go -2, 6, 1, 2, 3, 4, 5, 6. Okay, so this is my starting point. And remember what we said is you put the negative with the numerator, because we're going to go over 2, which is the x change, and down 5 because it's negative. Over 2, down 5, or you go down 5 over 2. So that puts you there. 1, 2, 3, 4, 5, 1, 2. And then you do it again. Down 5, 1, 2, 3, 4, 5 over 2. So I want you to plot at least 3 additional points. Down 1, 2, 3, 4, 5 over 2. And ultimately what you would do is you would connect, you get your ruler out, if you had a ruler, and you would just draw it so it goes through all those points, and you'd use the last point here and the ones that are furthest apart to determine how do you draw your line, because that gives you a better drawing. Okay, so I'm just looking through my exam here, see if there's anything I didn't cover. Okay, so now I need to go back and insert some old videos. So good luck on the test.